Okay, class, we are still in chapter 14, partial derivatives. All right, we're actually going to talk about the partial derivatives today in section 14.3. So we're going to use the example of heat index. Okay, so on a very hot day in very extreme humidity, it actually make us think the temperature is higher than it really is. Actually, our body respond to that. Okay, so however, in a drier temperature, we perceive the temperature to be lower than the actual temperature. All right, so this are all sort of implication in that. Let's talk about this first. Okay, so the heat index, which is called I, depends. It depends on two factors. One is the temperature. The other one is the humidity. We call it H. All right. So I, the heat index, is a function of the temperature and the relative humidity. All right. So how does that work? So here's a table of heat index, all right, produced by the National Weather Service. We'll take a look. All right. For example, let's take some extreme example here. If the actual temperature is 90 degree, however, the relative humidity is 90, you're going to think it's 96. Your body going to feel like it's 96 degree. All right. Your body can respond to the current temperature as 96. If the current humidity is 90 degree, 90% humidity, and it's at 90 degree, your body going to feel like it's at 119. That's a lot of difference. Let's take it to the other extreme. If the temperature is 100 degree right now, all right, if the humidity is 50%, then you're going to feel like it's 119 degree. If the humidity right now is 90%, then you're going to feel like it's the 168 degree, and that's kind of dangerous territory right here. All right, so the heat index probably is tells more story about the current environment than the reading of the temperature. All right, so what we're going to do is we're going to see how the temperature changed by 1 or 2 degrees, what happened to the heat index. Of course, there are so many different humidity. We can only focus on one. So we're going to focus on right now the relative humidity is 30 degree, and the temperature is 96 degree. If up and down 1 degree, what will happen to the heat index? That's what we're going to do. So we're going to treat the humidity as a constant. It doesn't change 70% the entire time. As we can see, we only jump 2 degrees at a time. If we go up 2 degrees, the temperature is going to rise from 120. The heat index is going to rise from 125 to 133. All right. If we drop 2 degrees, then the heat index drops from 125 to 118. So what does that mean? All right, let's look at the actual calculus right here. All right, so when the T equals 96 degree, all right, the actual temperature, remember, we're going to fix the relative humidity at 70%. So if you look at here, the 96 represent the change in temperature, can go up and down. H represent change, all right? However, this is actually the actual heat index function fixed at what? At the relative humidity at 70%. So if at 96 degree, we have 133 index right there. So minus that. So because the rise is what? Is a 2 degree. So we can see the heat index changes 4. What about before that? When you drop go back to 94, the temperature dropped to 118. Therefore, we use the 118 minus 125, of course, divided by 92, 3.75. We take the average of these two. So the average is 3.75. So what does that mean? So when the relative humidity is fixed at 70%, every degree changes rise, we're going to result in a 3.75 heat index rise. So it's well, 3.75. However, if you rise to 3 degree, then the heat index is going to rise by more than 10. So if you outdoor practice sports, if you expect the next hour or two, the temperature is going to rise by 3 degree, the actual temperature is going to rise by 3 degree, then expect the heat index to rise by 10 in a very relatively short time. and your body is going to have a hard time to readjust. So that just meaning you need to take what? More frequent water break in order for body to adjust the changes according to the heat index.